You're sitting still right now. Your chair, your desk, your body, everything seems motionless, peaceful, static, but it's not. Nothing is still. Nothing has ever been still. Not for a single moment since the universe began. Right now, as you read this, every atom in your body is vibrating. Trillions upon trillions of tiny oscillations happening constantly, relentlessly, without pause. The chair you're sitting on, vibrating. The air around you, vibrating. The screen in front of your face, vibrating. Everything, everywhere, all the time. You've heard this before, haven't you? Atoms are always moving. You nodded. You accepted it. You moved on. But did you ever stop and actually ask, why? Why are atoms vibrating? What's pushing them? Where does that energy come from? And here's the question that should really bother you. Why can't they just stop? Think about that for a second. If you push a ball, it rolls, then it stops. Friction takes the energy away. If you swing a pendulum, it eventually comes to rest. Everything in your everyday experience slows down and stops. That's normal. That's how things work. Except atoms don't do this. They never stop. Ever. Cool them down, they vibrate slower. Cool them more, slower still. But they never ever reach stillness. Why not? What's preventing it? Most people shrug. That's just how atoms are. They have energy. They move. But that's not an answer. That's just restating the mystery with different words. You're telling me what atoms do, not why they do it. And when you dig into the why, when you really push on this question, you discover something so strange, so fundamentally disturbing, that it changes everything you think you know about matter, about solidity, about reality itself. The answer isn't just surprising, it's unsettling. Because it turns out that stillness, the thing you think of as the default state of the universe, doesn't exist, can't exist. The universe forbids it. And once you understand why, you'll never look at a solid object the same way again. Let's start with something simple, temperature. You know what temperature is, right? It's how hot or cold something is. You feel it every day. Hot coffee, cold ice, warm sunshine. Simple, obvious. Except it's not what you think it is, not even close. Temperature isn't a thing. It's not a substance that flows into objects. It's not some invisible fluid called heat that moves from hot things to cold things. That's what people believed for centuries. They were wrong. Here's what temperature actually is. Atomic motion. That's it. That's the whole story. When we say something is hot, we mean its atoms are vibrating fast, bouncing around violently, slamming into each other with enormous energy. When we say something is cold, we mean its atoms are vibrating slower, more sluggish, less energetic. Temperature is just a measure of how aggressively atoms are moving. The thermometer on your wall, it's not measuring some mysterious heat essence. It's measuring how hard atoms are slamming into it. When fast-moving air molecules hit the thermometer, they transfer their motion, their kinetic energy, and the mercury rises. That's all a thermometer does. It counts atomic collisions. Now here's the part that should restructure your understanding. You've never felt heat in your life, not once. What you felt is atoms vibrating against your atoms. When you touch a hot stove, the atoms in the metal are vibrating so violently that when they collide with the atoms in your skin, they transfer enough energy to break chemical bonds. That's what a burn is. Atoms moving so fast, they tear your molecules apart. When you feel warmth from the sun, you're feeling photons, electromagnetic radiation, hitting your skin and making your atoms vibrate faster. The sun is 93 million miles away. It's not touching you, but its energy is making your atoms move. That's warmth, that's heat, just atoms in motion, nothing more. So now you understand what temperature is. But here's the question that should keep you up at night. If cold just means slower atomic motion, what happens when you remove all the motion? What happens at the coldest possible temperature? Do atoms finally stop? You might be thinking this is all theory, abstract physics, equations on a blackboard, something scientists believe but can't actually see. Wrong. We can see it. We've been seeing it for over a century. In 1827, a botanist named Robert Brown was looking at pollen grains suspended in water through a microscope. He noticed something strange. The grains were jittering, dancing, moving randomly in all directions for no apparent reason. He wasn't shaking the slide. The water was still. But these tiny particles were bouncing around like something invisible was hitting them, because something invisible was hitting them. Atoms, water molecules to be precise, slamming into those pollen grains from every direction, billions of collisions per second, each one giving the grain a tiny push. The random motion Brown observed, what we now call Brownian motion, is direct visible proof that atoms are real and they're moving. But here's what made it science instead of just observation. In 1905, Einstein calculated exactly how those particles should move if atoms were real and had a certain size and speed. He derived equations, made predictions, and when experimentalists measured the motion precisely, it matched Einstein's calculations perfectly. This wasn't philosophy. This was measurement. Einstein didn't just theorize atoms into existence. He gave us a way to weigh them, count them, prove they were there. Think about what this means. Take a glass of water, set it on a table. It looks perfectly still, calm, motionless. That stillness is a lie. If you could zoom in far enough, you'd see absolute chaos. Trillions of water molecules careening in every direction at hundreds of meters per second, colliding, bouncing, spinning. The surface looks flat because the chaos averages out. But underneath that smooth appearance is violence, constant, relentless atomic violence. You don't need to take this on faith. Get a decent microscope. Suspend some tiny particles in water. Watch them. You'll see Brownian motion yourself. Those random jitters, that's atoms. That's reality. Not theory, not abstraction. Observable, measurable, proven fact. Every atom around you, inside you, is in constant motion. And now you've seen the evidence with your own eyes. Here's where it gets truly strange. You'd think if temperature is just atomic motion, then if you cool something down enough, eventually the atoms would stop. Makes sense, right? Remove the energy, remove the motion, get cold enough, and everything goes still. That's what classical physics predicted. That's what your intuition says should happen. Your intuition is wrong. There's a temperature called absolute zero, minus 273.15 degrees Celsius, 0 Kelvin, the coldest anything can possibly be. At this temperature, according to classical physics, atoms should have zero energy, zero motion, perfect stillness, but they don't stop. They can't stop. The universe won't let them. This is where quantum mechanics enters the picture, and it breaks everything you think you know. There's something called the Heisenberg uncertainty principle. It's not a statement about our measurement tools being imprecise. It's not about technology. It's a fundamental feature of reality itself. The principle says you cannot simultaneously know both the exact position and the exact momentum of a particle, not because we're not clever enough, not because our instruments aren't good enough, because that information doesn't exist. The universe doesn't have it to give. Now think about what it would mean for an atom to be completely still. If an atom stopped moving, you'd know its momentum, zero, and you'd know its position, right there, fixed, motionless. You'd know both exactly. But the uncertainty principle forbids this. It's not allowed. A particle cannot have a definite position and zero momentum at the same time. So atoms must keep moving. They have no choice. We call this residual motion zero-point energy. Even at absolute zero, even when you've removed every possible bit of thermal energy, atoms still vibrate. They jitter. They fluctuate. This isn't leftover heat you failed to remove. This is the minimum possible motion, the floor of reality. You cannot go lower. Stillness isn't just difficult to achieve. It's physically impossible. The quantum nature of the universe demands that everything, always, everywhere, keeps moving. This is the part that should disturb you, really disturb you, because it inverts everything you think you know about how the universe works. In your everyday experience, stillness is the default. Objects sit there doing nothing until something pushes them. Motion requires a cause. You push a ball, it rolls. You stop pushing, it stops. Energy makes things move. No energy, no motion. That's intuitive. That's obvious. That's completely wrong. In quantum mechanics, motion is the default. Stillness is the impossibility. Atoms don't vibrate because something is pushing them. They don't vibrate because they have energy that needs to be dissipated. They vibrate because existence itself requires it. The very act of being a particle, of existing in space, of having any reality at all, demands motion. You cannot be a thing and be still. The universe doesn't allow it. Let me say that again because it's so counterintuitive. Nothing is making atoms move. There's no hidden engine, no mysterious force pumping energy into matter. The vibration isn't caused by something external. It's intrinsic, fundamental, built into the fabric of what it means to exist as a particle in this universe. The Heisenberg uncertainty principle isn't a limitation of our instruments. It's not that we're too clumsy to measure precisely. It's that there is no precise position to measure. The atom isn't secretly sitting in one exact spot while we fumble around trying to find it. The atom genuinely doesn't have an exact position. It exists as a smear of probability, a cloud of possible locations. The vibration isn't hiding the true position. The vibration is the true position. This should fundamentally restructure how you think about matter. You've been taught that stuff exists, solid, definite, located stuff, and sometimes that stuff moves. Wrong. There is no still stuff that occasionally moves. There is only movement. Matter isn't solid objects that sometimes vibrate. Matter is vibration that sometimes looks solid. The motion came first. The motion is primary. The apparent stillness, the seeming solidity, that's the illusion. That's your limited perception, failing to see what's actually there. You wanted a floor under reality. Congratulations, you found it, and the floor is shaking. Pick up anything near you, a pen, a cup, your phone. Feel that solidity, the weight, the definite edges, the way it resists your grip. That solidity is a lie, a useful lie, a persistent lie, but a lie nonetheless. The atoms in that object are vibrating right now, billions of times per second. They're not sitting still in neat little rows like the diagrams in your textbook showed you. They're oscillating, jittering, bouncing back and forth within tiny invisible cages. Those cages are made of electromagnetic forces, the repulsion between electrons, the attraction between opposite charges. The forces hold each atom in roughly the same position, like a ball bouncing inside a box. But the atom never stops bouncing, ever. So what you call solid is actually this. Atoms vibrating so fast you can't perceive the motion, held in approximate positions by electromagnetic forces so strong they resist your push. Solidity isn't atoms sitting still. Solidity is atoms vibrating in formation. A choreographed dance happening at frequencies so high it blurs into the illusion of stillness. Now heat that object up. What happens? The vibrations get more violent. The atoms start swinging wider, bouncing harder against their electromagnetic cages. Heated enough and the vibrations become so intense that the atoms break free of their fixed positions. They start sliding past each other. That's melting. The structure collapses not because you've added some magical substance called heat, but because you've made the atoms vibrate so hard they can't hold formation anymore. Keep heating. The vibrations become even more extreme. Now the atoms aren't just sliding, they're flying apart entirely. The electromagnetic cages can't contain them. They scatter in all directions. That's boiling. That's gas. Same atoms, same forces, just vibrating so violently they refuse to stay near each other. Solid, liquid, gas. You were taught these are three different states of matter, like three different things. They're not. They're three different intensities of atomic vibration. Same stuff. Different speed, that's all. Let's bring this home. Let's make it personal. Because this isn't just about atoms out there in the world. This is about you. Every atom in your body is vibrating right now. Your bones vibrating, your blood vibrating, the neurons firing in your brain as you process these words, vibrating. There is not a single still particle anywhere in your body. There never has been. From the moment you were conceived to the moment you die, you are motion. Constant, relentless, unending motion. Your body temperature, 37 degrees Celsius, 98.6 Fahrenheit. That number isn't measuring some abstract property. It's measuring how fast your atoms are moving. That's it. When you have a fever, your atoms are vibrating faster. When you're hypothermic, they're slowing down. When a doctor takes your temperature, they're essentially asking, how aggressively are this person's atoms bouncing around right now? The thermometer doesn't know anything about health or sickness. It just counts atomic collisions. Think about what this means for your sense of self. You feel solid, permanent, like there's a definite you sitting there reading this. But there isn't. Not in the way you imagine. You are not a solid thing. You are a pattern. a pattern of vibrations held together by electromagnetic forces, trillions of atoms, each one oscillating billions of times per second, somehow coordinating into the structure you call your body. The you that feels so permanent is actually a dynamic process. Atoms enter, atoms leave. You breathe in oxygen, breathe out carbon dioxide. You eat food, excrete waste. The atoms in your body today are not the same atoms that were there 7 years ago. Almost all of them have been replaced. But the pattern persists, the coordination continues. The vibration maintains its shape. That's what you are. Not stuff. Pattern. Not things. Process. And death, from a physics perspective, death is when that coordination stops. The atoms don't disappear. They don't stop vibrating. They keep moving, keep oscillating, just like they always did. But the pattern is gone. The coordination that made those atoms you dissolves. The vibrations continue. You don't. So let's return to where we started. Why do atoms vibrate? You wanted an answer, a reason. Something that explains atomic motion in terms of something deeper, something more fundamental, something familiar. Here's the honest answer. There isn't one. Atoms vibrate because they must. The structure of quantum mechanics requires it. The uncertainty principle demands it. Existence itself enforces it. There's no hidden mechanism underneath, no tiny springs pushing atoms around, no mysterious energy source feeding the motion. The vibration isn't caused by something else. It is the something else. It's bedrock. It's the floor. You can't dig deeper because there's nothing deeper to dig into. You thought stillness was normal. You thought motion needed explanation, but you had it backwards. Stillness was never normal. Stillness was never even possible. You just thought it was because you can't see atoms, because your eyes blur trillions of oscillations into the illusion of calm surfaces and solid objects. The stillness was always in your perception, never in reality. The universe is not a collection of still objects occasionally disturbed into motion. The universe is motion. It always has been. It always will be. From the first moment of the Big Bang to the last dying stars, everything vibrates, everything moves. Stillness is the fairy tale we told ourselves because we couldn't see what was really happening. And here's the thing that should give you wonder instead of discomfort. We figured this out. Humans, fragile, short-lived, limited humans, discovered that the stillness we perceive is illusion. We built theories that predicted atomic motion. We designed experiments that confirmed it. We measured zero-point energy. We calculated the uncertainty principle. We saw through the illusion and described what's actually there. That's not a failure to explain. That's understanding, real understanding, not comfort, not familiar analogies, truth. If this changed how you see the world, even a little, then subscribe to Feynman Physics. This channel exists to show you the universe as it actually is. Not comfortable, not simple, but true. Every video takes research, writing, and effort to get right. Subscribing costs you nothing, but it helps keep this channel alive. It tells the algorithm that this content matters. It means we can keep making videos like this one. So hit subscribe, turn on notifications, share this with someone who thinks they understand what solid means. And next time you touch something, anything, remember what you're really feeling. Atoms, vibrating, pushing against your atoms. Nothing is still, nothing ever was. And now you know why.